Okay, you should have already watched the video on order of operations, and now we're going to talk about the distributive property. You probably learned about this a little bit in middle school, but let's say we had an expression that looked like this. 4 times the quantity 1 plus 2. Now, normally we would say that according to order of operations, we would do what's in the parentheses first. So we would add 1 plus 2 and we would get 3. 4 times 3 would give us 12. But there's another way that we could solve this, and we could multiply this 4 by each term that's inside the parentheses. So we would have 4 times 1 plus 4 times 2. 4 times 1 would give us 4. 4 times 2 would be 8. 4 plus 8 is equal to 12. Okay, so we get the same answer either way. And I know most of you are probably thinking this first way is much easier. Why do I even need to mess with the distributive property? Well, what happens if I replace that 1 with a variable? Now I have 4 times x plus 2. I can't do anything with what is in parentheses here. X plus 2, I can't combine that at all. So the only way that I have to simplify is to use the distributive property. And again, all you're going to do is take what's outside the parentheses, in this case a 4, and multiply it by both terms inside the parentheses. So I have 4 times x, which is just 4x, plus 4 times 2, which would give me 8. And that would be my simplified answer. Okay, so down here on the problem, or on the bottom, we have some example problems. I'm going to do the first one for you, and then I'm going to ask you to do B and C and bring them into class to show me that you've watched this video. Okay, so again, we're taking what's outside the parentheses and multiplying it by both terms inside the parentheses. 7 times 3w. 7 times 3 is 21, and then I leave the w. And now I have 7 times, we're going to consider this a negative 5 since it's minus 5 in here. So 7 times negative 5 would give me negative 35. Alright, I'm going to leave B and C for you to do to show me that you have watched this video. And we're going to move on to this last little part about combining like terms. Many times to simplify an expression or solve an equation, we're going to need to do what's called combining like terms. Okay? And so first you need to know what like terms are to know whether or not you can combine them. Okay? So like terms would be any terms that have the same variable and the same exponent. Okay, so both terms have to have the same variable, x, y, z, whatever letters used, and they have to be raised to the same power. Okay, so here's a couple examples. 2x plus 4x. They both have x's, and they don't have any power here, so they're technically raised to the first power. So same variable, same exponent, we can combine these two. Okay, 3y squared minus 2y squared. Both terms have a y, and the y is raised to the second power. So those would be considered like terms. Okay, unlike terms are terms that have a different variable or a different exponent. So one or the other or both are different from each other. This expression right here has 4 terms, and they are all unlike. Okay, this first one is 3x. Alright, there's no other term that has just an x by itself. This one is x squared. There's no other term that has x raised to the second power. There's no other term with a y at all. And then 7 is just a number, and none of the other terms are just numbers by themselves. They all have variables. Okay, so these are unlike terms, and you cannot combine them. There's nothing that can be done to simplify this expression because there are no like terms. Okay, so down here on the bottom, here's 3 examples. Okay, it says simplify and if not possible, write that it's already simplified. So you're going to go through and look for like terms. Okay, this first term here, 4y to the third power. I don't see any other term that is raised to the third power. So I'm just going to go ahead and bring this term down here. I know this expression is going to have 4y to the third because there's nothing that I can combine it with. Alright, the next term is 2y. So I'm looking for any other terms that have just a y, not raised to any power, and I see minus 8y here. So I can combine these two terms. Alright, so 2y minus 8y. Well, 2 minus 8 would give me negative 6. So I'm going to have negative 6y. And then I have a 5 here by itself. There's no other term that has just a number, so I'm going to bring down that plus 5. And this expression now is simplified because every like term has been combined. Okay, we're going to do the same thing here. I have 7m, okay, and the m does not have a power. So I'm going to go look for other terms that have an m. So I have 7m, I have 2m, and I have 4m. I can combine all three of these terms together. 7 plus 2 would give me 9, plus another 4 would be 13m. And then I have this other term in here that there's nothing else it can be combined with, so I just bring it down, plus 5p. Alright. Last problem. Now this puts together the two things that we've been talking about. I have this 7 here multiplied by the quantity 3x plus 4, which means that I need to use the distributive property. So I'm going to multiply 7 times 3x and 7 times 4. To start with, I'm just going to copy this 3x from the beginning. So 3x plus 7 times 3x is 21x, and 7 times 4 is 28. Okay, now that I've done the distributive property and gotten rid of my parentheses, I'm going to look for like terms. I have a 3x here and then 21x. They both have x's not raised to a power, so I can combine them. 3 plus 21 would give me 24x plus 28. And that would be simplified because there are no more like terms.